Imagine this. Two motors, same voltage, same current, same total wattage. Both built with the same frame size. Both running under the same load. One is an AC motor, the other is a brushless DC. Which one would give you more usable mechanical power? The answer isn't as obvious as you might think. Let's keep this comparison 100% fair and theoretical. We're not talking about a small hobby motor versus an industrial giant. We're talking about two motors designed for the same electrical input, same voltage, same current, and therefore the same electrical power. So, if both consume say 1 kilowatt of electricity, which motor turns more of that into mechanical power at the shaft? Brushless DC motors, BLDCs, are known for high efficiency in compact designs. Because the rotor has permanent magnets, there's no rotor current loss. That means less wasted heat and more torque per watt, especially at lower and medium power levels. AC motors come in two main flavors, induction and synchronous. Induction motors are robust and cheaper to build but lose some efficiency to rotor heating. Synchronous AC motors, on the other hand, eliminate that rotor heat loss and can match or exceed BLDC efficiency, especially in high-power continuous duty applications. Torque is where things get interesting. A BLDC can deliver high starting torque instantly and maintain strong torque over a wide speed range with proper electronic control. That's why they're so common in EVs, drones, and robotics. AC induction motors generally have lower starting torque, unless designed with special windings or controlled by a variable frequency drive. The synchronous AC motors can match torque performance, but their control systems are more complex and typically reserved for industrial setups. Heat is the silent limiter in any motor. BLDC motors generate less rotor heat, so at the same electrical input, they waste less energy internally. But they do concentrate heat in the stator windings, so cooling must be well designed. AC induction motors spread the heat between stator and rotor, which can make them more tolerant of short overloads, but at the cost of some efficiency. Synchronous AC motors remain stable under continuous heavy loads, making them king in large-scale applications like power plants, compressors, and big pumps. Same input power aside, there's also the question of how each motor keeps performing over time. BLDCs have no brushes to wear out, so maintenance is minimal, but their performance depends heavily on the quality of their electronic controllers. AC motors, especially induction types, are famously rugged. Even without advanced electronics, they can run for decades with minimal servicing, making them ideal for environments where repairs are costly or access is limited. So, same voltage, same current, same total input power. Which motor gives you more usable mechanical output? In small to medium scale setups where efficiency, torque control, and compact design matter, a brushless DC motor often comes out ahead. But scale things up. A push for continuous heavy-duty operation and a synchronous AC motor can be the clear winner. The truth is, in engineering, it's never just about AC or DC, it's about the right tool for the right job. What motor would you choose for your project? Let's talk in the comments. This is Tech Explorer 31, and the exploration never stops.